Okay, living things transform energy. So plants transform radiation energy into chemical energy and into kinetic energy. Animals transform the chemical energy also into kinetic energy, and this energy is conserved. It's just transferred, not created or destroyed. This energy is used, it's usable energy, but when it's used from plant to animal, and the animal uses that energy, some of it is lost to the environment as heat energy. So that is our first law of thermodynamics, energy is conserved, and our second law of thermodynamics, that when energy is used, some of that energy is transferred to the environment as heat energy. Okay, so how does this happen? How does the energy get transferred? So let's take an example. An equation that we're familiar with. I'm going to get my pen. Okay, so the space shuttle used fuel, hydrogen fuel, plus oxygen to form water. But in the process, produced energy. And that energy is in the form of light energy, we can see that, and heat energy, I'm sure they could feel that there, and mechanical energy to lift that sucker up off the planet. So mechanical energy. This is called an exothermic reaction. You've probably all heard of that, exothermic. And that means exo, release of thermic, heat. So release of heat. So heat is being released in this reaction. So going from the reactants to the products. We know that heat is released. Okay. We also know that for this reaction to take place, and you can see right here, there had to be some activation energy. They had to activate it. Okay, so here let's put our formula back up here. So H2 plus O2 gives us our 2 molecules of water. Okay. My chemical equation right here. Wait a minute, I think we're missing something. Oh yeah, that's right. We need a 2 right in front of there. Okay, so it's 2 hydrogen molecules to 1 oxygen molecule. Gives you 2 molecules of water. Okay, so we know that water is very stable. We know that hydrogen and oxygen are somewhat unstable. So there's a little bit, it takes a little bit of energy, just a little bit of energy, to split hydrogen. And it takes a little bit of energy to split a molecule of oxygen. But then to combine, so we've got now 2 hydrogens and 2 oxygens. But then there's a huge amount of energy released when 2 hydrogens combine with an oxygen. Okay, so let me put that into words here. So when the molecules bond together, there is a release of energy. When molecules are broken, when the bonds of the molecules bonds are broken, takes energy. Okay, so let's go back over here. Oops. Oops. Okay, so let's go back over here. So it takes a little bit of energy to break these bonds right here, because it takes energy to break bonds. But then when these bonds form, energy is released. And there's more energy released when the bonds form than it took to break them. So the net energy is positive. There's a lot of energy. There's a lot of energy. And that's the energy it took to get the space shuttle off the ground. Okay, so what does this have to do with life and glucose? Okay, well, glucose, let's take a look at our glucose molecule. We have C6H12O6. This is our glucose molecule. And remember, there's stored energy in here, potential energy. And in make sure I get my numbers right, the presence of oxygen, carbon dioxide is formed, and water is formed. Oops, do I have too many? Let's see. Too many. Let me try that again. Small and looser. That's better. Okay, so it's a balanced equation. What I was doing was balancing the equation. So you want to make sure that you have the same number of carbons on this side as you do on this side, which we do. same number of hydrogens on this side as you do on this side, which we do, and the same number of oxygens on this side as we do on this side. Okay. So we all want to be able to get the energy out of this glucose molecule to do work. If we were to put a spark to sugar and break these bonds in glucose and in carbon dioxide, we would get a lot of energy. And the products would be carbon dioxide and water. We would get the energy in the form of light and heat, an explosion. But for life, we don't want the energy in the form of light, and we don't want it in the form of heat, although some of it is going to come off in heat. We want it in usable energy. And so to be able to do that, glucose is metabolized. So metabolism is all the chemical reactions in the body. So we want to metabolize glucose, which means that we want to go through a process, a step-by-step process, to take this energy out of this glucose molecule very slowly. In glucose. So step by step, to use the energy in glucose slowly. This process is called cellular respiration. Okay, so cellular respiration, the process by which cells harvest the energy stored in organic compounds like glucose. Okay, next video, we're going to talk a little bit about photosynthesis and the ATP molecule. Okay, I hope you found that interesting.